Hey everyone, so in this video we're gonna apply the cancellation formula for the log. Alright, so let's start with the formula itself. So the formula says that if I have a log base a of a to the x, this eventually gonna cancel to x. So in other words, the log function with base a, you're gonna cancel the exponential function which is the a, right? A exponents, right? So all of this disappear and the final answer will be obviously the x in here. All right, so this is our formula we're gonna start with now. So the idea would become here, if I'm gonna do it for the first one, log 2 base 2 of 16. So what I want to do here, I want to transform 16 in a function of 2 exponent something. All right, so I have to find that something. All right, so it's not really difficult. So what we're going to do is we're going to break down the 16 into prime factorization. So you can do it either with this method. 16 is going to be a 4 times 4. And then the fourth, they're gonna divide 2 and 2. This one, 2 and 2 again. So this is gonna be 2 to the fourth. All right. Or you can simply write 16 here and do the prime factorization. So what will be the first number different than 1 that divides 16, and that's gonna be a 2. So you're gonna do 16 divided by 2. And that's going to give you 8. And then you redo the same thing all over. What the first number different than 1 that divide 8, that's going to be another 2. And then 8 divided by 2 is going to be a 4, and so forth. So 4 you can divide by 2, you're going to get 2. 2 divided by 2, you're going to get 1. So once you hit the 1, the prime factorization will be the numbers over here. And you can notice here is the same answer. So that's 2 to the fourth. All right, so we end up with the same answer either ways. So now, how can I transform my expression for a? So I have here log 2 of 16. And since 16 equals to 2 to the fourth, so I'm going to substitute this there. So it's going to be log 2 or 2 to the fourth. And you notice here that the formula I can apply it, log 2 and log 2 and exponential 2. That's going to cancel each other. And the final answer, it should be a 4. And that's it. So now let's apply the same formula again for b. So the whole idea again is to get log here. If I have log x, that's basically is log base 10 of x. All right, so I know here the base is 10. Therefore I'm gonna express whatever I have expression here in function of 10. All right, so I have 10 millions and I want to figure out 10 millions, what will be the exponents of 10 exponents what. All right, so this is pretty easy once you know this fact. If I have a 10, this is a 10 to the 1. If I have 100, it can be 10 squared. All right, if I had 1,000, that's going to be 10 cube. So once you know that, the rest is easy. So what you notice here, that the number of zeros in here is reflected in this exponents. So the only thing you gotta do, count how many zeros you have there. All right, and obviously there are 7 of them. All right, so what I can write, the 10 millions is gonna be equals to 10 to the 7. So going back to my expression in b. All right, so this is log remember, is 10. Yeah, log base 10 of 10 millions, and that should be equals to log base 10 of 10 to the 7. And again, the cancellation formula applies to this, to the log base 10 and 10 exponents. That's gonna cancel out, and the final answer should be equals to 7. And that's all.